Hey everyone, and welcome to today's Explainer. Today we're unpacking a really fascinating dual narrative, Reduction Tech's revolutionary planned methane scrubbing technology for the Alberta gas fields. It's an incredible look at not just the physical hardware required to literally clean the air, but the strategic regulatory playbook needed to actually get it deployed out in the real world.
Think about that for a second. How do you actually scrub the sky? It's a serious question. In the energy sector, we know exactly how to capture emissions when they're trapped inside a pipe or a tank. But how on earth do engineers capture diffuse, invisible methane emissions that have already escaped standard physical controls? Once it's out there in the air, just drifting across a field, the traditional tools literally don't work anymore. So we need an invisible solution to tackle an invisible problem.
Okay, let's dive into this. Here is our roadmap for this innovation playbook arc. We're splitting our journey into the physical hardware and the strategic regulatory hurdles. So we'll start with the invisible methane challenge, move into the three-tiered deployment architecture, and look at measuring the unseen. Then we'll pivot over to the regulatory playbook and wrap up with expected outcomes and scale.
Right, moving right along to Section 1, the invisible methane challenge, solving diffuse emissions. Our primary problem here is persistent low-level leaks and those massive super emitters that easily evade traditional leak detection and repair methods.
So to catch these fugitive emissions, Reduction Tech relies on a process called atmospheric oxidation enhancement, or AOE. You can basically think of this as nature's atmospheric detergent. By accelerating the in-situ oxidation of methane and volatile organic compounds using naturally occurring hydroxyl radicals right there in the boundary layer, they're essentially using invisible chemistry to clean the air directly in active gas field regions.
Let's keep the momentum going. Section 2, three-tier deployment architecture, scaling up.
And this brilliantly illustrates how the physical field engineering actually scales from the micro to the macro. First up, we have the pad-level emitters. These are your small skid or pole-mounted units with a 50 to 150 meter radius, set up directly at well pads and compressor stations. Next, they use downwind oxidation curtains. Picture these as linear arrays spaced about 50 to 100 meters apart and stretching up to 800 meters long, completely designed to intercept methane plumes traveling on prevailing winds. And finally, for those really high emission clusters, they build regional OH nodes. These are massive, 10 to 30 meter towers integrated with weather stations and LiDAR to raise the background hydroxyl levels across the entire boundary layer. It's like a giant invisible net.
This hardware integration flows straight into a highly structured four-phase deployment timeline. Phase 1 is pre-deployment, taking a brisk 4 to 6 weeks for critical site surveys, emission mapping, and wind field modeling. Then Phase 2 is installation, which takes just 2 to 4 weeks to get those emitters, curtains, and towers up and running. Phase 3 is the operational pilot. That's 6 to 12 months of continuous hydroxyl emission and real-time monitoring. And lastly, Phase 4 is either decommissioning or a massive scale-up to full-field deployment. It goes straight from modeling to continuous action.
Which brings us to Section 3, measuring the unseen, the MRV system. Because as they say, you can't manage what you can't measure, and you definitely have to prove the technology actually works.
To definitively show this system works, Reduction Tech utilizes an incredibly robust measurement, reporting, and verification, or MRV, data architecture. We're talking about an instrument package packed with open-path methane sensors, highly sensitive cavity ring-down spectroscopy units, and VOC analyzers. They feed all of this into cloud-based analytics using upwind and downwind differential analysis. By measuring the air right before it hits the oxidation curtain and immediately after, they can mathematically prove the exact volume of methane removed. It's absolutely crucial for validating the tech.
All right, shifting gears a bit for Section 4, the regulatory playbook, looking at strategy and framing.
Now, what's really interesting about this slide is how it contrasts traditional regulatory fear against Reduction Tech's framing. Because having great hardware means absolutely nothing if bureaucracy keeps it switched off, right? The traditional fear is that any new gear on a gas pad triggers complex facility licensing, the kind of soul-crushing red tape that takes years to clear. Reduction Tech bypasses this entirely through some very clever framing. They classify their emitters strictly as temporary, non-intrusive environmental protection equipment. They aren't processing gas, and they aren't combusting anything. Therefore, they argue they absolutely shouldn't be regulated like traditional industrial equipment.
They explicitly align this framing with the Alberta Energy Regulator's existing rules. Under Directive 060, they position the tech as voluntary mitigation that enhances compliance without touching any venting equipment.
For Directive 017, the MRV sensors are presented as supplementary environmental monitoring, not replacements for mandated measurement. And crucially, for Directive 056, because these emitters aren't pressure or processing equipment, they fall nicely under temporary equipment exemptions. This strategic alignment ensures the technology acts as a force multiplier for Alberta's existing methane reduction framework, all without triggering that burdensome new facility licensing.
Central to this whole regulatory acceptance is their environmental safety framing. It is vital to understand that this system requires absolutely zero chemical release. Hydroxyl radicals already exist naturally in our atmosphere. They have microsecond lifetimes, they literally do not accumulate, and they create no environmental residues. So there is no soil interaction, no water interaction, and absolutely zero impact on atmospheric chemistry outside the target zone.
Because of this, their core messaging to the AER becomes a highly strategic mantra. Let me repeat this quote because it's key. This technology does not alter equipment or require a facility license. This technology does not alter equipment or require a facility license. By repeating this verbatim throughout their applications, Reduction Tech ensures that operators, regulators, and environmental scientists all clearly understand that this is a safe, non-intrusive addition to a site. It's essentially greasing the wheels for rapid pilot approval and deployment.
Let's bring the energy back up as we zoom out for our final section. Section 5. Expected outcomes and scale, looking at the environmental payoff. When the engineering and regulatory strategies align, the payoffs really scale up. Now, while reducing methane is obviously the primary goal to combat greenhouse gas warming, the air quality co-benefits are just incredible. By accelerating atmospheric oxidation, the system actively reduces volatile organic compounds, lowers the ozone formation potential, and decreases hazardous air pollutants. This leads to drastically improved downwind air quality for nearby communities and workers. And these co-benefits perfectly align with broader federal ECC regulations protecting public health. So, the crucial point is 10 to 40%. That is the expected quantitative outcome of this deployment, and it's huge. Reduction Tech anticipates a 10 to 40% faster methane oxidation rate in their treated zones. To put that into perspective, that means significantly reduced plume persistence and a massive chunk of diffuse methane completely eliminated from the atmosphere before it even has a chance to spread further.
Which brings us to a really compelling final thought. By combining atmospheric chemistry with a highly deliberate regulatory strategy, Reduction Tech is paving the way for a totally new type of environmental protection. Will invisible chemical curtains become the new standard for energy fields worldwide? It's a scalable, technology-neutral mitigation tool that just might change how we scrub the sky. Thanks so much for joining me on this explainer, and keep learning.